Here we have a fourth order polynomial, a quartic equation, and we want to find all real solution to this equation. We notice that x equal to 0 is not a solution to this equation, because if you replace x equal to 0 here, you get 1, which is not 0. So with this observation, we divide both sides of this equation by x squared. So here we get x squared minus 2x minus 13 minus 2 over x plus 1 over x squared equal to 0. We collect the terms appropriately. So here we have x squared plus 1 over x squared. So we collect this term and this term. And likewise, we have minus 2 times x plus 1 over x minus 13 equal to 0. So for this equation, we now can use a substitution method to simplify the equation. So assume that y is equal to x plus 1 over x. So here we can replace for y. And if we square both sides of this equation, we get y squared equal to x squared plus 2 plus 1 over x squared. So y squared minus 2 term from this relationship is equal to x squared plus 1 over x squared. Therefore, using the substitution for y, this equation simplifies. For this parenthesis, we replace y squared minus 2 minus 2y minus 13 equal to 0. Simplifying this equation, we get y squared minus 2y minus 15 equal to 0. So we solve this quadratic equation for the two roots of this equation. We get y minus 5 times y plus 3. In other words, what are the two numbers that if you multiply, it's minus 15, and when you add them together is minus 2, and the two numbers are minus 5 and plus 3 here. So the roots of this equation for y is y equal to 5 and y equal to minus 3. So now we replace for y in this equation here and solve the equation for x. So if we replace for y 5, is equal to x plus 1 over x, multiplying both sides of this equation by x, we get x squared, and simplifying, minus 5x plus 1 equal to 0. And here we can use the standard formula to solve this equation. So x is equal to minus 5 minus minus 5 plus or minus square root of minus 5 squared minus 4 AC. 1 times 1 divided by 2. From here we find that x is equal to 5 plus or minus the square root of 21 divided by 2. Another time we take y equal to minus 3, and from here we find that minus 3 is equal to x plus 1 over x, multiplying and simplifying by x, we get x squared plus 3x plus 1 equal to 0. And using the quadratic equation, we find that x is equal to minus 3 plus or minus square root of 3 squared minus 4 times 1 times 1 divided by 2. And from here we find that x is equal to minus 3 plus or minus the square root of 5 divided by 2. So here we found 4 real roots of these two equations. 2 real roots are here, and the other two real roots are here. So this equation, in fact, has uh, four, four real roots.